Okay, video one of the first 5 problems that you will see on your test on Monday in the order that I'm going to give them. I strongly suggest that you do each problem. If you got anything wrong on your test, then you should do all 3 problems to try to get to the point where it's just mechanical and perfunctory. There's our first word of the day. We're going to do something called learning how to learn perfunctory. And then hopefully 2 weeks from now, you understand why I'm asking you to know what perfunctory means. Perfunctory means you just do it. You're so used to doing it, you know the drill. It's a perfunctory exercise. You brush your teeth in the morning. That's a perfunctory skill. All right, I hope. All right. So the easiest problem on the test, in my estimation, was finding the average rate of change of a function. Average rate of change of a function is not calculus. It's basically algebra 1. Okay, so here is, I guess you can see all 3 situations. So the average rate of change of the function 5x from 1 to 3. I want a closed interval. Closed interval is dot to dot, 1 to 3. So I make a table. I put 1 in, 5 times 1 is 5. I put a 3 in, 15. I look at the change in the table. From 5 to 15, which is up 10 units. I look at the change in the table on the other side, which is the change in x, and I see up 2. 10 divided by 2 equals 5. The average rate of change from one place to the next is over 1 up 5. That's the rate at which you are changing. Okay, so that's that answer. All right, so let's do another one. And this was problem number 18 on your test. It will now be problem 1. This will be problem 1 on Monday's test. Let's find the average rate of change of g of x from 2 to 10. Okay, it looks like I'm going to make a table. I'm going to put x squared minus 4x as my calculation. And I am going to look at the x values. I'm going to start with an x value. And I'm going to plug it in. 4 minus 8, 4 minus 8, 4 minus 8 is negative 4. And then I'm going to put 10 in. 10. 100 minus 40 is 60. Looks like I went up. I know I got a down arrow here, but I went up 64 units. That's my change in y. It looks like from 2 to 10, I went up 8 units. So therefore, I am going to look at 64 divided by 8. The average rate of change of this function is 8 to 1 over that interval. Okay, problem number 3. The average rate of change of this function, e to the x, from 0 to 1. I know that e to the 0 is 1. I know that e to the 1 is e. So the change in the table, y2 minus y1 is e minus 1. Over 1 minus 0, okay, which is approximately 2.71 minus 1 divided by 1. So there's an approximation here of 1.71. Your exact answer would be e minus 1. I think I captured that entire board. There you go. So that's question number 1 on Monday. Question number 2, I think the next easiest problem on the test. Next easiest problem on the test. Okay, I think we can see where I'm going to work. I'll do all my work here. I'm going to get a better marker. Let's see what we got here. Better marker. How come there's so few markers in this room? Let's hope this baby works. Let's hope we got a good one just to get through these 5. Okay, we're up and running. All right. X of t equals 3t squared minus 4t plus 5. And we want to write the equation of the line tangent to this function at t equals 2. Okay, now x of t, we've talked about, is a position function. You can think of it as big F. What do you need to write the equation of a tangent line? You need a point and a slope at that point. at that t value. Okay? Nobody works with y equals mx plus b. You get away from algebra 1, nobody works with that. All right? So I would hope that if I give you the point AB, that soon you will start to write x minus a gets me b. When I plug in, all right, we're doing a conversion. Conversion is based on subtraction first and then division. That's how you do conversion, subtraction and division. So whatever number you have here, if it's -5, then you write x plus 5 in parentheses. And if you want to get a 7 out, then write 7. Okay, that's going to be worth 0.5 point on Monday's test. Okay, the other 1.5 is going to come from doing the derivative, finding the slope at that point, and writing it in the form of an equation, a linear equation. All right, so back to this problem. All right, so we need a point. All right, the point is x of 2, which is equal to 3 times 2 squared minus 4 times 2 plus 5. All right, so I now know that if I put a t value of 2 into the calculation, it comes out as 12 minus 8 is 4, plus 5 is 9. Therefore, for 0.5 point, t minus 2 plus 9 is what I'll be looking for. Now I need the slope at that point. Slope comes from taking a derivative of a function. In this case, we're looking at velocity. The velocity would be 6t minus 4. That's grandma's velocity. I need to know her velocity at 2. 12 minus 4 is 8. So the answer to this equation, equation line tangent, is 8 times t minus 2 plus 9. We'll do another problem now. We'll do 3 in a row. This time I'll give you velocity. V of t. X of t is like big F. Big F is our position function. Little f is our velocity. And f prime is our acceleration. Now I'm asking for the equation of a tangent line to velocity, which means the acceleration function tells you how your velocity is changing. So let me give you a function. V of t equals t cubed plus 8t. And I want the equation of the tangent line to velocity at t equals 1. Okay, so if t equals 1, I need to know what grandma's velocity is an hour from now. T equals 1, so I plug 1 in. 1 plus 8 is 9. Okay, so I know that an hour from now, she's traveling at 9 miles an hour. Hopefully she's coming out of a rest area, okay, because she's definitely not traveling very fast. Now I need to know her acceleration, which is the derivative of this. I have to use the derivative to assign the slope value, and I want the derivative at 1. But first I have to find the derivative of velocity, which is 3t squared plus 8. I now need the acceleration at time 1. It looks like it's 11. So putting it all together, let's see. We have that. I erased it for spatial purposes. I now have 11 as my equation of the line tangent. Do one more. Sometimes position is not written as x of t. Sometimes it's written as s of t in science textbooks. And I want the equation of line tangent to this position function, which you can think of as y. Velocity you can think of as y prime. And acceleration you can think of as y double prime. I'm going to do the equation of a tangent line to the position function 2t squared minus 4t plus 1. And let's do the equation of the tangent line at t equals 10. Okay, again, what's the first thing I have to do? I have to find my position or my value at t equals 10. And I know I already have this to start the equation of my tangent line. All right, so what do I need? I need to plug 10 in now to find out the value. So I have to do S of 10. 200 minus 40 plus 1. 200 minus 40 plus 1 is 161. Okay, so I've started to write the equation in tangent. Now I need the slope, the rate of change of this function at 10. So I have to take a derivative. Rates of change are found through the derivative process, which in this case is my velocity for Grandma on Route 91, which is 4t minus 4. If I want to find the rate of change at 10, then I plug 10 into 4t minus 4, and I get 36. Okay, on your test, that was problem number 10. On Monday's test, this will now be the second question that I ask you. Okay, third problem. The easiest way to get 2 points on your test on Monday is to do the following problem. Find the average value of the function f of x equals 5x minus 3 from 2 to 9. It actually might be the easiest problem on the test. Understanding it, well, might hopefully move along in that direction when I do the third problem. Or I guess the second problem. I'm going to do the second problem and explain step by step what you actually did in this calculation. But to get an answer, mechanics come before concept. To get the right answer, you got to do the right process. This is how you can get a quick 2 points. The average value. You take the function and you integrate the function from 2 to 9. This assigns the heights of the rectangles. This assigns the widths. Almost done. Divide by 9 minus 2. That's it. All right, for 2 points. You take the function, you integrate. So I'll do it again. You take the function, you integrate, which means you've got this. You integrate the function from 2 to 9, and then you divide by 9 minus 2. All right? Second problem. And I will tell you what you just did. All right, but hopefully you can get a correct response. And now we're going to find the average value of x squared plus 2x from 0 to 4. Okay, now I'm going to graph this very quickly. Going up at 2 to 1 through the origin. I'm going to change this to minus x squared. Okay, this is now minus x squared, which means it comes back like that. And this happens to be 0. That happens to be 4. Okay, so what is step 1? Step 1 is you write minus x squared plus 2x. Now, what that function actually does is it tells you each altitude, every y value on this curve is what that is telling you. Okay, we now integrate. Integration is adding up each one of these strips of area. So now I have an area statement from 0 to 4. I have an area statement. Now, if you've been listening carefully when I say values, right, you're actually finding values when I do this part of the calculation, gives me a y altitude, a height. And so when I'm trying to find average value, I'm trying to find the average height. Okay, so now by dividing by 0 by 4 minus 0, 4 minus 0, I'm actually dividing by the width. I'm dividing area by width. I think that gets you height. All right, so if I divide this area by the width, I get a particular height. And I would say the height I'm getting would be right about here. That would be my average value. Because if I draw a rectangle there from 0 to 4, if I draw a rectangle from 0 to 4, then this area here offsets this area. And that's how I get my average value, which is a y altitude. That's what's going on conceptually. Now, I will change to a new function. And again, just the mechanics of getting 2 points on Monday's test. If you practice all three, I'm hopeful that you're in a different place. Let's look at h of x is equal to e to the 3x plus 4. I would like the average value of that function from 5 to 10. All right, so what do? You integrate from 5 to 10 the function I give you. Step 1, integrate from 5 to 10 the function I give you, and then divide by 10 minus 5. Okay, so hopefully we'll do one more quick one. Just the mechanics. Let's do p of x. I want the average value of p of x of 2x plus 9 from 1 to 20. Should be put in brackets, closed interval, from 1 to 20. You integrate from 1 to 20, the function I give you. And you divide by the interval, 20 minus 1. Let's do one more. I want the average value of the sine of m of x equals the sine of x squared plus e to the x. I want the average value from 2 to 9. Okay, you integrate the function I gave you. From 2 to 9. And you divide by 9 minus 2. If you put the time and effort into doing what the problems we just did, then this is going to be your third problem on the test on Monday, and I hope you get it right. Okay, next problem that I think going from hardest to easiest, not necessarily the expert on, what should be the easiest. Some problems are easier for others. Right? But point of inflection, finding the equational line tangent to a point of inflection. So a point of inflection is where concavity changes. Okay, it's where concavity changes. This is a concave down interval. This is a concave up interval. Okay, and I'm looking for that value. Okay, step 1, I give you a number. Well, you got to find the number. You got to find the point on the curve. So we do y prime equals 3x squared minus 6x plus 7. And the point of inflection is where the second derivative changes signs and equals 0. And the second derivative is 6x minus 6. It looks like the critical number where this function changes sign and equals 0 occurs at x equals 1. All right. I need the equation of a tangent line. I have an x value, and I want the equational line tangent to this. I better find the point on that curve at x equals 1. So I plug the number 1 in, and I get 1 minus 3 is negative 2. Negative 2 plus 7 times 1 is 7. Negative 2 plus 7 is 5. 5 plus 2 is 7. A 1 gets me a y value of 7. I now have x minus 1 plus 7. I need the slope of this calculation. That comes from the derivative. If I put 1 in, I get 3 minus 6 plus 7. 10 minus 6 is a slope of 4. That is the equation of the tangent line to this function at its point at its point of inflection. I'll graph this for you very quickly. I start at height of 2. I'm going up at 7 to 1. It's got some kind of bend, and then it goes back up again. Okay, so this is what that function looks like, and this is that equation. Except that I should have been going up at 4 to 1, so I never bent very much. So I'll come back and do it again. 2, going up quickly, 7 to 1, and then so it looks like this. That's what that function looks like. There's the point of inflection, and that is the equation for x minus 1 plus 7. Okay, now we'll do another one. Write the equation aligned tangent to the point of inflection of minus 2x cubed plus 6x minus 4. Hope this marker lasts, and I'll get some better ones. So y prime, we need y prime. We need to assign slopes. This is position. Acceleration is down here. Okay. Minus 2x cubed becomes minus 6x squared plus 6. That's what assigns slopes at any instant. Y double prime is minus 12x. It looks like 0 is the most important number here. This function changes signs at 0, right? And it also equals 0. So I now know that x minus 0 is going to be part of my equation. Obviously, I don't need those parentheses and that subtraction. I'll put them there. All right, now where am I? Oh, I'm at negative 4. That's my position at that x value. I need to know at what rate I'm changing. I got to go to the slope function and plug in 0. Looks like I'm changing at 6 to 1. There's my equation on my line tangent to this function. Okay, now let's graph this function from right to left. I'm starting at negative 4. Oh yeah, 0, negative 4. I got a feeling that's right where my point of inflection is going to be. And it says I'm going up at 6. Oh yeah, 6 to 1. Oh yeah, we kind of knew that right there. Right, that's the equation 6x minus 4. And then what am I doing? Minus 2x cubed means that I must have been doing this and then this. If I put that in a graph, that's what that calculation looks like. Now, just a little bit later. No, I'm not talking at all. Just going to do the next problem. Talk about why that's important during the second half. So let's look at f of x. Third problem. 2x cubed plus 18x squared minus x plus 10. Write the equation on a line tangent to the point of inflection of this curve. How do we do it? We need f prime of x for slope. We need f double prime of x for position of the point of inflection for the x value. So f prime of x is 3 times 2 is 6x squared. 2 times 18 is 36x minus 1. That's going to get me my m value. Okay, f double prime, 12x plus 36. Okay, I can see that this equals 0 at x equals negative 3. So the equation of my line tangent has x plus 3 as part of that calculation. Okay, I got to find the slope and the position. So I go back to position. Okay, that's going to go here. So I've got to plug in negative 3. Minus 3 cubed is minus 27 times 2 is minus 54. You will find that this answer is 3 times that, 162 when you do it. Minus a minus 3 is plus 3 and plus 10. Okay, so you got some math to do here. Whatever this number is, you double it and change the sign. So when you put these two together, you'll get 108. 3 plus 10 is 13. If I haven't made a mistake, that is 121. Straight math. I couldn't make a mistake. Right, but I'm not going to check my work because I got to get these videos up and I got to do it quickly. Okay, so, because I got another 7 of these to make today. Today's Wednesday. And I got to be in Turner's in the afternoon. I got class this morning, and I got 2 hours and 45 minutes of math help tonight. So that's why I make these careless errors, because I'm flying. All right, now I got to find the slope. Where do I find the slope of f? Its derivative. And I've got a very critically important number, -3. I'm going to do f prime of -3. If I plug -3 in, I should get a 2-to-1 ratio opposite. There's a reason for that. We'll talk about it in the second half. -3 squared is 9 times 6 is 54. That had better be -108. -3 times it is -1. When you put these numbers together, you always get the opposite of the first one. So -54 minus 1 is -55. We'll see if this makes sense by graphing f of x quickly. So f of x starts at an altitude of 10. It's going down at 1 to 1 right there. And then it turns quickly back up. But, oh yes, these are both influences quickly back up. So that's what that looks like. I don't like what I wrote here, -3. So -1, -3. Okay, so it looks more like this. This is already, so that's where I turn. So I'm going down at 1. So it looks like this. Okay, that's my -3. All right, that's what that function is going to look like. Okay, all right. Next problem. And I'm really running out of ink here. Let's see if I got something over here that might work. Yeah, I got blue. This will get us through to the last problem we're going to do, which is, let's see, I did 1, 2, 3, 4. What's my 5th one? Average rate of change. Oh yes, finding. This is a very mechanical problem. Understanding it will require us to conceptually look at it in more depth during the second half. But right now, I'm on a mission to get some people the right answers. All right, because I'm giving you a grade. So mechanics comes before concept. How do you get? There we go. Good. See each problem. So I'm going to give you an integral, which is really the area under the sine curve. This is the area under the sine curve from 2, which is right about here. 2 is right about there. And x squared, if I give you an x value like 10, well, really you're out here at 100, right? And you're going to be looking at how the area accumulates under this curve, right? And we're going to look at the rate at which this is changing at any instant. So if I said put a 10 in, then you would be looking at all the way out here somewhere, you got 100, and I would be looking at how is that thing changing? How would the calculation change at that instant? All right, and the mechanics of this is pretty straightforward. So we're going to practice the mechanics 3 times in a row. And I think if you do this 3 times in a row, to me, it's a 5-second question. We'll see if it's a 5-second question for you at the end of doing it 3 times in a row. Step 1, take the derivative of x squared, 2x. Multiply it times what you get when you plug it in there, and that's the sine of x squared, minus take the derivative, which is 0. All right, you can stop there, obviously. That's a constant. You don't have to do the rest of it, but you plug it in, the sine of 2. That's the mechanics for taking the derivative of big F. We're going to do it again. Now we're going to take the derivative of big F if we go from 3x to x cubed of et dt. So what do you do to find f of x? You take the derivative of x cubed, which is 3x squared. Then you drop it into the variable, which is times e to the, when I drop it in, x cubed. Then you subtract. You take the derivative of the lower limit. The derivative of 3x is 3. And then what do? You take the lower limit and you put it into the variable, e to the 3x. That assigns slopes to this accumulation function. Next one. We're going to take the derivative of this calculation. How do we do it? We take the derivative of 5. which is 0. And we drop 5 in, 25 minus 2. And then we subtract. We take the derivative of the sine of x, which is cosine x. Okay, I'm going to do this again because I ran out of room. Okay, so we're after f of x. I'm going to get a better marker. F of x is the derivative of this accumulation function. I take the derivative of 5, 0. It's not changing. There's no variability. Times, I take 5 and I drop it in, which is 23, 25 minus 2. Obviously, you don't have to do that. But then you subtract. The derivative of sine is cosine of x. And then you drop it in. So times, drop it in gets me sine, and I'm squaring it, sine squared x, minus 2. Okay, I hope you get a fighting chance sometime between now and a week from Friday, this Friday, to get that right. Hoping you get it Monday. Okay, but then you got Thursday next week and Friday next week as well. So I'm stopping this video, and I'm hoping that you got 10 points on these 5 problems. If you spend some time, you're going to be quarantined here soon. I can't think of anything I'd rather do than do calculus problems in quarantine. That's the silver lining of this pandemic.